IM-1 Nova C launch.
Discovery, go at throttle up.
Coverage. Yeah, baby. Going 3 out of 4 today. Let's see what happens. Yeah, Unky sitting here like I don't understand what that means. That's cute. Hey, why don't you go fuck yourself, pal? Alright, so let's go check out the IM-1 mission here. Hey, it's after hours, man. Sorry. I have to rip into some people from time to time. Okay. Here, let's pick up the coverage. We're 25 minutes out for the IM-1 mission.
Thank you so much. I appreciate it, and good luck tonight.
All right, thank you.
All right, so once the Nova C lander gets to the moon, there are 6 instruments on board.
NASA, of course, their sound with the volume all the way up is near non-existent.
The first one is this. It's a lightweight laser retroreflector array, or LRA. This passive optical instrument is a collection of 8, as you can see here, about half-inch reflectors or mirrors used for measuring distance. So the plan is, after Nova C lands,
I'll be right back. 1 second.
Future landers or spacecraft flying near Nova C's lunar location can cast a laser towards the surface.
Thank you.
And these retroreflectors will bounce the
Be right
light
back.
back
1 second.
to the approaching craft. That reflected laser light will help determine how close the spacecraft are to the lunar surface, ensuring a smoother landing. So really, it's similar to when you're reversing your car and watching a camera to let you know just how close you are to an object. All right, so for more than... So let's go back now to Houston, where Josh Marshall is standing by live at Intuitive Machines with an update. And Josh, what is the latest?
Thanks, Megan. And if you're just joining us at home, welcome to Nova Control in Houston, Texas. Right now, flight controllers are monitoring launch pad activity and staying in communication with SpaceX's launch control in Florida, where we have another team working side by side with SpaceX to monitor Nova C's fueling and launch readiness. After launch, flight controllers working each of Nova Control's 12 positions will prepare for first contact with our Nova C-class lunar lander. That process won't start until a spring force gently pushes the lander away from the launch vehicle's second stage, which is scheduled for about 48 minutes after liftoff. After separation, our lander's orbit is called trans-lunar orbit. This enables Nova C to reach lunar orbit in about a week, but requires a lunar lander with a very capable engine. Nova C was tailor-made for NASA's CLIPS initiative and supporting commercial lunar exploration. It's a pillar of Intuitive Machines' lunar access services, and we took a deep dive into what makes Nova C qualified for this historic undertaking.
The Nova C was our version of a liquid oxygen, liquid methane lander, and we went about imagining that into existence.
Intuitive Machines' Nova C-class 3D printed engine took its first breath of liquid methane and liquid oxygen in 2018 on an airstrip at Ellington Airport in Houston, Texas.
We didn't have enough money for a facility with blast walls and water suppression or water deluge. So we had to test outside in the environment of Houston, where the temperature is about 100 degrees and the humidity is like the same. And we are having an 18-hour day, rolling out to the runway. It was brutal. But we did it to get the critical test engine data we needed to build our own engine.
I have donuts.
Designed, manufactured, and controlled in space by Intuitive Machines, Nova C's structure is primarily carbon composite.
We needed to build the lightest weight structure we could. That meant honeycomb aluminum core with composite face sheets, composite struts, and most importantly, linerless composite propellant tank. Man, what a challenge that was.
Between the engine, carbon composites, software, and electronics required to build a Nova C lunar lander, it took an incredible amount of touch labor to get to the launch pad.
We worked very closely with San Jacinto Community College to create a certification course for technicians. where they would take these certifications. We then, in Intuitive Machines, would give them an internship and test them out in the workplace. And anyone that showed the aptitude to be a really good technician, we've hired on the spot.
Nearly all of the lunar lander's payloads are mounted to its exterior, including 6 NASA-provided payloads that will help lay the foundation for Artemis missions. Embry-Riddle Aeronautical University's Eagle Cam, designed to deploy off Nova C right before landing to take third-person perspective images. The International Lunar Observatory Association's camera system, mounted at exact angles that could capture images of the Milky Way from the lunar surface. A data center technology demonstration by Lone Star Data Holdings.
Lone Star!
Infinity, Columbia Sportswear's thermal reflective insulation used in many of their outdoor products, will help protect Nova C from extreme temperatures in space.
We've got brilliant ideas. And if we can help facilitate those startups to help build this economy, I think that raises all boats. And it's as serving as the transportation leg to the moon, we're happy to accommodate those kinds of companies.
Let's go.
The IM-1 landing site is called Malapert A. It's named after 17th century Belgian astronomer Charles Malapert.
Astronomer!
And it's
Astronomer!
expectedly made of lunar highland
Astronomers!
material, similar to the material studied during Apollo 16, which was also launched from Launch Complex 39A, where we have more from Megan.
All right, thanks, Josh. And actually, not far from the Malapert A landing site is the Malapert Massif region, and that is one of the 13 candidate regions being considered.
Yes,
for the
astronomer.
Okay, so a second NASA instrument on board the Nova C lander is NASA's Radio Frequency Mass Gauge, or RFMG. The instrument is essentially a fuel gauge to estimate the amount of propellant in spacecraft tanks in specifically a low-gravity space environment. So during this mission, RFMG will estimate the amount of propellant in Nova C.
I'm here to save my girlfriend.
Once proven,
Hi, honey.
RFMG technology would demonstrate significantly more accurate measurements of a fuel tank's fill level without requiring a thrust to provide a force upon the fuel in order to measure it, as current technology does. For the first time in more than 50 years, astronauts, including the first woman and person of color, will travel to the moon as part of NASA's Artemis program. To get there, SpaceX and NASA teamed up to develop the human landing system. Here's a closer look at your Artemis Moon Minute.
With Artemis 3 planning to return humans to the moon for the first time since 1972, NASA and its commercial partners continue to develop the systems needed to land crews safely on the lunar surface. SpaceX will provide and operate a moon lander for NASA's Artemis 3 mission called Starship Human Landing System, or HLS. During Artemis 3, NASA's Space Launch System rocket will launch 4 astronauts aboard the Orion spacecraft for their multi-day journey to lunar orbit. The Starship HLS, powered by 2 variants of SpaceX's Raptor engines, will launch uncrewed on a super heavy booster to lunar orbit to pick up the crew. Once on board the HLS, 2 crew members will head to the surface of the moon, where they will live and work for about a week, collecting samples and performing science experiments. Once they're done, they'll get back into Starship to the orbiting Orion and return to Earth. That's your Artemis Moon Minute.
For more on SpaceX's Starship Human Landing System, let's go back to Jesse Anderson live at SpaceX headquarters in
They said it was 60 seconds.
Jesse.
It was, in fact, 60 seconds.
Great. Thank you,
Yo,
Megan.
what up, Jesse?
Down at Starbase, Texas, we're continuing to build, test, and fly Starship, the world's most powerful launch vehicle ever developed. A fully reusable Starship is capable of carrying up to 150 metric tons to orbit and up to 100 passengers. We completed 2 test flights last year, and 2024 is lining up to see even more Starships take flight. We're still in the testing phase, but major milestones like flying at a high cadence, full system reuse, and on-orbit refilling are key priorities. Refilling on orbit will enable the transport of up to 100 tons all the way
That's pretty
to
awesome. Dude,
down
look
at Starbase, we're gearing up for Flight 3 of Starship. We have
Wait,
a fully stacked vehicle on the pad for the first time since Flight 2 in November of last year.
Is that a render or not? I
Ready
can't
to
tell.
Go through pre-launch testing to get ready to fly.
Dude.
We're also building a second Starbase launch tower to further increase Starship's flight opportunities. Also in testing, our
I
engineers
need
are putting
it.
all systems necessary to make a trip to the moon possible, such as propulsion, life support, and even the elevator that you see here, which will take crew and cargo from the Starship hatch opening down to the lunar surface.
That's
In
the
partnership with
astronaut
NASA,
skeletons. That's what they
SpaceX's
look like.
Starship Human Landing System, or HLS, will put the first Artemis astronauts on the moon. We are part of the global team, which includes Intuitive Machines, that will further exploration of the moon under the Artemis program.
Please.
SpaceX will perform one uncrewed demonstration flight before the Artemis 3 mission, which will be the first human surface expedition since 1972. To that end, SpaceX has been hard at work getting Starship ready for its moon missions and ultimately Mars. There's so much to look forward to, and it's just incredible that
it's gonna be
humans
awesome.
are finally going back to the moon, and the efforts of SpaceX and Intuitive Machines get to play a vital role in that. For those of you who have just joined, we're just about 15 minutes from launch of the IM-1 mission. Let's check back in with Josh at Intuitive Machines. Josh?
Thanks, Jesse. We're counting down the minutes to launch and looking forward to Intuitive Machines firing its Nova C-class lunar lander's engine about a day after liftoff. Nova C uses an environmentally friendly mixture of liquid methane and liquid oxygen. It's a propulsion system with deep roots to NASA's Project Morpheus. Morpheus was a prototype lander engineers at NASA's Johnson Space Center used to integrate technologies for future spacecraft that could land on a variety of destinations in our solar system. The project integrated NASA's autonomous landing and hazard avoidance technology designed to enable a spacecraft to identify, descend, and find a safe landing site that is relatively flat and free of large boulders, rocks, and craters.
That's the SLF.
In the video on your screen, you can see that signature blue fire synonymous with liquid methane and liquid oxygen engines. That's the same fuel used on Nova C. From December 2013 to December 2014, Morpheus completed 13 free flight tests at the north end of Kennedy's shuttle and landing facility. And joining me now is our co-founder and chief technology officer, Dr. Tim Crane. Tim, before starting Intuitive Machines with your fellow co-founders, Steve Altimus and Dr. Cam Gafarian, you were working on other things at Johnson Space Center to include Project Morpheus. What can you tell me about Project Morpheus and how that foundings of technology
that's killer.
led
Look at
to
that
us
thing.
getting to the launch pad today with your company?
Well, one thing I can tell you is I get chills watching that footage because it takes me right back. But this is a journey that clearly our prop technology was a big part of Morpheus we brought forward. Also the all-hat, the autonomous landing, hazard avoidance task, a lot of our navigation, the way we do software.
That's awesome.
The way we test our systems. And even
know
the
how cool
discipline
that is.
about
That's so
knowing
difficult to do.
some technology needs to wait for a future date so we can get to flight. All of that came from the Morpheus experience.
And, you know, just about a year ago, you got to see those Project Morpheus tanks again, but this time they were in your facility and you were testing them with your company. What can you tell me about speeding up
Fuel is
innovation
stored there,
through
guys.
NASA's Reimbursable Space Act agreement?
Well, NASA really is a national treasure in terms of knowledge and capability, and in some places, equipment. And we had a supply chain issue with some of our tanks, and we needed to get our test rig up and running. And we knew the Morpheus tanks were in surplus, and reached out to NASA, and they facilitated getting those tanks to us so that we could proceed with testing while our flight tanks were coming in.
And real quick, while you have you,
stored in the balls.
why liquid methane? Why liquid oxygen?
That's a good
Well,
question.
in the near term, it's very easy to work with. It's environmentally friendly. It's non-toxic. It's very robust to changing conditions. Down the road, it's the exploration fuel of the solar system, and we can make it on Mars for bringing spacecraft back from there, so we don't have to take all the fuel with us.
Well, Tim, I know you're burning back to get back into mission control, watching your team that you fostered throughout all these years, and listening to that IM-1 mission loop. We do appreciate your time today, and thanks for stopping in.
Thanks, Josh.
NASA instruments on the Nova C lander for this IM-1 mission is the Lunar Node 1 Navigation Demonstrator, also called LN1. That's much simpler. It's similar to when you use GPS to get to a destination. Let's take a look at how it works and what it will do to help support future surface and orbital operations.
Lunar Node 1 is meant to be a demonstration of how we can use various navigation technologies to figure out where you are in and around the moon. I'm holding in my hands the Lunar Node 1 mass simulator. We use this build to test out our vibrational modes, put on a shake table, and also do fit checks with the lander itself. Inside of our payload, we have multiple electronics boards that fit within this chassis that is a little bit about a half U in size. You can see our external connectors here where we have our data and power to the lander itself. And within here, we have multiple boards that do the power regulation, our data control, our FPGAs, all those kind of electronics pieces are in here, as well as a small S-band radio that attaches up underneath this top radiator in order to distribute this heat and then to talk to the antenna, which mounts here. This is the same size and build as the flight payload. It's just not covered in MLI or some of the other materials that you'll see on the flight build itself.
Now, IM-1 is the second launch of a lunar lander under NASA's Commercial Lunar Payload Services Initiative. The first CLPS launch was with Pittsburgh-based Astrobotic. The mission was called Peregrine Mission 1. It successfully launched last month on a ULA rocket, but afterwards, Astrobotic reported a failure in its propulsion system, which prevented the spacecraft from
Hey, they
landing
blanked
on
out
the
the
moon.
Picari
10
sweat.
days later,
What the
Peregrine burned up
hell?
after
It's
re-entering
blanked
Earth's
out. It's
atmosphere.
blurred.
An anomaly review board will release its findings to what happened once complete.
Face, they blanked out the Picari sweat.
Join me now to
What
talk
the
about
heck?
NASA's CLPS initiative and its
Bruh.
benefits and risks is Sandra Connolly. She's the Deputy Associate
Picari
Administrator
sweat.
for NASA Science. Good morning to you.
Good morning, Megan.
So talk to me about some of the key takeaways as NASA moves forward with commercial lunar vendors.
That's some
Yeah,
H in
so
my head.
the Commercial Lunar Payload Services Program is super important to NASA. It really is transforming our method of doing business. It's leveraging industry's emerging capabilities of actually providing end-to-end service
Picari
for us.
sweat
So
dudes.
rather than us having to build our own, we can now
understand.
procure it. And it's not only, we're not the only customer. Other government organizations, industry, academia from around the world are all going to procure these services. And there is risk associated with it, though. So we recognize that as we're evolving this capability.
Yeah, so I was just going to ask you that. I mean, because we know that there are risks, and we've
Spacecraft is
accepted
go for
those
launch.
risks.
There we go.
Spacecraft is go for launch. We just heard a call for that. What
Hey,
involvement
all right.
does NASA have when our commercial providers are assessing the risks?
So what's really
Guys, I'm going to run ads here so nobody gets ads during the launch. I hate ads. I hate ad time. I hate doing it. I'm disabling the channel points the second it annoys me any more than it already has. But a lot of people get in like right when the thing launches, and I would hate for like the thing to be launching on the thumbnail and somebody click on it and see like a Applebee's ad or something. Nothing against Applebee's. It's just if I had to choose between like a charbroiled steak from Applebee's and like charbroiled flame trench from Rocket. I mean, you can't eat a flame trench, but I'd want the flame trench. So I'll see you on the other side, Ray.
right? So you've got industry and academia as well. But focusing on Intuitive Machines,
Oh,
which
yeah,
is
yeah,
our
Phantom, I
purpose
will.
for being here tonight. We're super excited about their efforts here. So
Yeah, that's right, Fancy. You're
they
not
actually
wrong.
have another payload that's going to be launching later this year. They're going to be delivering the Prime 1 drill and spectrometer, which is actually going to support our in situ resource utilization and support a future human presence on the moon.
Sandra, thank you so much. We're excited to see what CLPS
Well,
can do
DJ,
for NASA
the
and
five-head
and for
move would be to
humanity,
put the
really,
steak
what we
in
plan
the
to
flame
do
trench and
with,
have
the
the
Artemis
rocket
program.
cook
Thank you.
your
And
steak.
Thank you so much.
Go Falcon
Then you
9.
see the
That's
rocket
right.
launch,
Go
and then you got a
IM-1.
nice steak after.
Perfect. All right, so let's send it back to our friends at SpaceX in Hawthorne, California, as they walk us through the final moments of the countdown, and then I will see you guys after launch.
Thank you, Megan.
Awesome. Thank you so much,
I'd eat
Megan.
it, Ian.
At
I'd do it.
T-minus just under seven
It
and
would
a
be
half
this
minutes,
little
all
city, but
systems
whatever.
are currently a go for an on-time liftoff. Next up, in just about a couple minutes, the structure next to the vehicle known as the strong back will begin to retract away from the vehicle.
this part
But
right
while
here.
we wait for that, let's talk about what it takes to actually get to orbit. In order to get the rocket and payload into any orbit, the rocket not only has to go up really fast, but it also has to go sideways.
chill has started.
As we ascend, we tilt the engines, and that turns the rocket horizontally. To help demonstrate this concept, an image of a firing cannon from a really high mountain is what you can see there on your screen. The cannonball will arc, and then good old gravity will pull it back down to Earth. As you increase the power, the cannonball will arc and land farther and farther away. Eventually, if you could continue to increase the power, the cannonball will end up in free fall around the Earth. Basically, gravity is pulling down on the cannonball, but it's going so fast that it never hits the ground.
RP1 load is complete.
This arc that constantly misses the Earth is called an orbit. Falcon 9 effectively does the same thing as the cannon in this example, and it provides enough power and horizontal velocity to the second stage carrying the spacecraft, enabling the spacecraft to be placed into orbit around the Earth. Now, you'll be able to see this today by watching the orientation of Falcon 9 after liftoff. The rocket will go straight up until about T plus 10 seconds, at which point we will begin that shift in orientation, gimbaling the engines so that Falcon 9 can go horizontally really fast. So be sure to look out for that after liftoff.
No one cares.
Now again, at T minus
please.
5 minutes and 38 seconds, all systems are currently go for liftoff. The strong back is going to begin retracting away shortly in preparation for that retraction. The clamp arms, which are located just around the second stage, just below the fairing, will begin to open. Once those are fully open, then the TE, or the strong back, can begin to recline away from Falcon 9. And you can see that on your screen, those clamp arms just below the fairing there. Now the vehicle is nearly fully loaded with propellants, and we did hear a call out that
there was 3 scheduled, 714 scrubbed. Weather wasn't good enough.
We are still loading blocks.
Yeah, thumper it is what it is.
And there's that call out that we are
I'm not sure of the trajectory
that process for that strong back retraction. Propellant loading is continuing on the vehicle and will complete at T minus 2 minutes. The range is currently green and ready to support liftoff. And if for some reason we do not launch today, we do have a backup opportunity on Friday, February 16th at 1:12 a.m. Eastern time.
Basi, if you care, MS-26 launched.
Strong back retract in progress.
Parametry constructor rocket
and
no set normal.
There. The strong back retraction is now in progress, and it will be slow and slight, but we should see those clamp arms begin to open up there. And there you can see it on your screen. Those clamp arms are now opening up. Again, once they are fully open, that will allow the transporter erector, that structure next to the vehicle, to begin to retract away.
Very rare, Keen. But don't bring the bad juju here right now, dude.
You should see that TE begin to move away, very slow and slight. But at this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene, fuel, and liquid oxygen. And there you can see on your screen that TE is now moving away from Falcon 9. Falcon 9 uses 2 propellants, a refined form of kerosene called RP1, or rocket propellant 1, as a fuel. And
all right, hold on. We know it uses Keralox. Guys, check this out. Look at that. See that line right there? Fuel lines for the lander. Because there's a fueled lunar lander in there. IM-1 is inside of that payload fairing. I don't know if you guys caught it. There's an extra set of fuel lines that usually isn't there that are going into the fairing, which is super freaking cool.
Into the vehicle, and in addition to
these
2 propellants,
super cool. It's a Methalox lander. That's awesome.
Source. The combustion of RP1 and liquid oxygen is
would you look at that? Would you just look at it?
Would you look?
Would you just look at it? Would you look at it?
We did hear a call out that stage 1 liquid oxygen loading is complete. Coming up next, in the next couple of minutes at T minus 60 seconds, Falcon 9 will go into startup. That
Where's this going?
Rocket's autonomous
it's going to the moon, man.
Will have taken over the
this is a commercial lunar payload services mission, man.
She's
going to the moon.
We will light those Merlin 1D engines for liftoff. The
Could we say this is a tri-propellant rocket at the moment?
And the Falcon 9 team is tracking no issues on the vehicle. We are currently green for weather, and the range is ready to support a Tier 0 of 1:05 a.m. Eastern Time.
Right, Ian? Tom Mueller out there writing checks and snapping necks.
And just waiting for the call out for liquid oxygen.
There you go.
Right on time. Stage 2 liquid oxygen loading is now complete. That concludes propellant loading on the vehicle. That means that Falcon 9 is fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Weather is 90% chance of
Ground gas closeout.
good weather.
Okay, T's gonna vape.
Good weather for
I'm
T0.
Ron Burgundy?
And we are just about 30 seconds away from Falcon 9 going into startup. Now that propellant loading is complete, we are beginning to vent out the lines,
See
the
'em?
propellant lines on that.
Look at the
transport
fuel
erector
lines.
there,
Oh, they
so
cut
you see more
the...
of those
Damn it,
black clouds
SpaceX. Jimmy,
around
go
the
back.
vehicle.
Jimmy! Come back! Damn it!
Startup is coming up here in a couple seconds.
Startup initiated.
Falcon 9 is in startup.
There we go.
Great call.
Yeah,
That means
yeah,
that
yeah.
the internal
The one
flight
we saw
computers have
land
now
this
taken
afternoon,
over
Blue,
the
landed on
launch
LZ2. This
countdown.
one's going to 1,
We are
dude.
now just waiting
It's
for
gonna
the
land
flight
right
to
next to
go
another
from the
one.
launch director.
It's freaking
LD,
sweet, dude. I
go
love
for
this.
launch.
Launch director reports go.
An excellent call. All systems are go for launch of Falcon 9 with the Intuitive Machines lunar payload.
All right. Send
30
it.
seconds.
30. Falcon heavy, but sparser. Nodders. 15.
15 seconds.
All right. Let's go.
T minus 10.
Sound suppressor is
9,
prime.
8, 7, 6, 5, 4, 3, 2, 1.
Ignition.
Ignition. And liftoff.
Back to the moon,
Go
baby. Let's
SpaceX,
go.
Go IM-1 and the Odysseus lunar lander.
Good ignition. Falcon 9's cleared the tower. 10 seconds in.
Pitching downrange.
There's the call for the pitch downrange.
Stage 1 propulsion is nominal.
T plus 20 seconds. Vehicle's now 1 kilometer off the deck, traveling at 400 kilometers an hour.
Falcon 9 has successfully
Stand by for the call for
lifted
power
off
and
from
telemetry.
Pad 39A at Kennedy Space Center, carrying the IM-1 payload. Now, during ascent, we tilt the engines, the technical term being gimbaling,
Good call for
and
power
that
and
turns the
telemetry.
rocket horizontally. And
Jesse. 55 seconds into the flight, vehicle's now traveling over 1,000
Mach
kilometers
1.
an hour. 8 kilometers in altitude, Mach 1. Stand by for the call for max Q. Maximum dynamic pressures, peak aerodynamic and thermal
Max
loads
Q.
on the forward sections of the vehicle. There's the call for max Q. 1 minute 16 into the flight. Vehicle now almost 2,000 kilometers an hour at
Vac chill has started.
18 kilometers. And vac chill
we
is
have a
started.
few events coming up in quick succession here. That will be Miko.
So the second stage engine is now getting primed for ignition and thermal conditioning on the motor to make sure that the motor is at the right operating temperature to utilize the cryogenic propellants.
Separation, which is where the
Semi-cryogenic
first and
propellant.
second stage will separate. And the first stage booster will begin its trip back to Earth. And the second stage vehicle will ignite that MVAC engine
2 minutes in.
with SES-1.
4,800
or
kilometers an
second
hour,
stage
44
engine
kilometers in
startup 1.
altitude, coming up on main engine
And then the
cutoff.
boost back burn will
Shut
begin
up, Harvey.
on the first stage vehicle, which is one of 3 burns that's required for the vehicle to make its way back to today's landing zone. And this burn assists with the vehicle to
There's engine
reorient
cutoff,
itself
2 minute
back
18
towards
seconds.
land.
Stage separation confirmed.
Got a good separation on the stage. First stage will now turn around and fly back to Florida.
Back ignition.
Got a good call for upper stage ignition.
On boost back startup.
First stage turning around in the
And
glow
there we
of the second
saw
stage
and heard
engine.
those
Boost back burn
call-outs
has
from
begun.
Miko. Stage
Great flow
separation,
phenomenon happening.
SES-1
Look at
and
the top.
boost back burn
Oh,
startup
that's
on the
killer.
first stage.
First stage now moving back
Some
towards
great views
the
there.
landing site, doing a
Now the first
RTLS,
stage
a
is
return to
currently
launch
performing
site.
its boost back
Yes.
burn. This is where we ignite a few of the engines to bring the trajectory towards the landing site.
Okay, second stage
coming up
at 3
here
minutes
shortly
and
will
5
be
seconds.
very
Second stage is 7,100 kilometers an hour, 102 and 103 kilometers in altitude. First stage slowing down for its boost back, 2,200 kilometers an hour and decelerating at 105. Fairing separation confirmed, exposing the IM-1 lander to the vacuum for the first time.
And an amazing view of the
Sweet.
IM-1 payload
It's freaking
attached
cool,
to Falcon
man.
9's
Did you
second
see
stage.
that? Did you see the landing legs?
Fairing deployment has been confirmed, and we will be attempting to retrieve these fairing halves once they fall back to Earth with our recovery vessel, Bob.
I'll tell you in a second, someone. I thought you'd never ask.
Both vehicles are on nominal trajectory.
3-minute 45. Second stage indicating
And some
8,100
good
kilometers an
call-outs
hour.
there.
129 kilometers in altitude. First stage is coasting after the boost
And
back
in
burn.
about
Speed is
3 minutes, there will
2,000
be a couple more burns
kilometers
on
an
our
hour
first
at
stage to prepare
119
for landing
kilometers.
at landing zone 1 at Cape Canaveral. Again, we've completed the boost back burn on the first stage. That's the first burn of 3. The next burns coming up will be the entry burn and then the landing burn for the first stage vehicle.
Okay, first
Now we
stage
are
at
at
4
T
minutes
plus 4
17 has hit
minutes
its
and
apogee,
17
120
seconds
kilometers
into
in
today's
altitude.
mission. IM-1
First stage is at its highest point.
14th launch this year, and the lunar lander
It is a
on board
monster
could
of a
be the
vehicle,
first
S-Master.
US
It's
moon
crazy.
landing since the Apollo program ended more than 50 years ago.
Okay, we're seeing the first stage at T plus 4 minute 36 seconds. You're seeing the first stage start to accelerate here. That means it's past its highest point, so it's past apogee. It's now falling back down towards the ground. Second stage at T plus 4 minute 48 is 10,500 kilometers an hour at 156 kilometers. First stage 2,300 and accelerating at 112 kilometers.
Light 3 of those M1D engines.
T plus
Starting
5,
with the
everything's
center
looking
E9
good.
engine, followed shortly afterwards with the E1 and E5 engines. This helps slow the vehicle down as it enters back into the Earth's atmosphere. Now we need to slow down the vehicle to reduce re-entry forces, and that helps us to recover and reuse the first stage.
Lander's light, Tessa.
And again, what you're seeing
5
on
minute
your
25,
screen is a view of
12,300
the
on
MVAC
the
engine on the
second
second
stage is
stage.
164.
And you can follow the
First stage is now below the Kármán line, 90 kilometers, traveling at 3,300 kilometers an hour. Coming up on the best part, the entry burn here, where Falcon 9 will fire one engine, 3 engines back to one engine to slow itself down and also protect itself from thermal reentry forces. The first stage is going fast enough to experience reentry. You should see some plasma accumulation on the grid fins here. What this thing is designed to do, what this entry burn is designed to do, is push the plasma away from the vehicle. It is called supersonic retro propulsion. And it will be engaging here momentarily. There it is. First stage entry burn has begun. One engine, 2.
And there you can see that the entry burn has begun with those engines relit.
It went to 3, but it...
Stage 1 and 3, shut down.
Okay.
Stage 1, FTS.
And a very
There we go. Grid fin steering it in. You can see
Very
the lights
quick
at Cocoa
vehicle
Beach and
burn
Port Canaveral over there.
Trajectories.
great call out.
6 minute 40 seconds. Second stage is 17,800 kilometers an hour at
that was the
168.
second of 3 burns.
First stage now slowing down. 18 kilometers off the deck at 3,600 kilometers an hour. Coming
The
in
next
hot.
and final burn.
She's
will
coming
be
in
the
hot.
Burn. That's just a center E9 engine burn, and that helps slow the vehicle
The
down
arrow's
just in
really,
time for landing.
really washing
That's
that thing
coming up
around.
in just about 15 seconds or so.
7 kilometers off the deck from the first stage, 1,500 kilometers an hour.
Stage 1 transonic.
It is now transonic, moving into the subsonic regime. Should be getting a landing burn here momentarily.
Stage 1 landing burn.
T plus 20 is 7 minutes 20 seconds. Landing burn should begin here. A little bit of a delay on the feed. 500,
Stage
400,
two.
300, 200
landing burn
meters.
has begun. Let's watch as Falcon 9. Let's
Stage
watch
1
as Falcon 9
Landing
touches
legs.
down for landing.
We got a good landing. Good landing.
Stage
And a
1
great
landing burn.
view there.
Great view of darkness. Stand by for second stage engine
That-
cutoff here.
That is
Sprang. 7 minutes 56 seconds. Second stage engine cutoff. Orbital speed 26,688 kilometers an hour at 164.
and just heard SECO 1 as well as a confirmation of good orbit for our Falcon 9 second stage carrying our IM-1 payload. Now, with that landing,
Looking good.
that marks SpaceX's 273rd
It looks like there was
recovery of
some
an
wishy-washiness
orbital-class
with the
rocket,
telemetry there, guys, but it
including
looked okay.
First stage landings for Falcon 9 and Falcon Heavy.
But I was noticing some weird stuff with the calls there. The calls weren't matching up with these numbers here, and it said the first stage was on the ground with move with a velocity component, which we'll chalk that one up to the antennas being broken or something.
Over to Megan at KSC. Megan?
What's that stuff flying around? You're looking at solid nitrogen here. Anytime you see the MLI, the Mylar wrap right there, start kind of moving around a little bit, it's because there's cold gas nitrogen thrusters on the back of the second stage, and that's basically used to steer it when the engine isn't moving. So like say, you're orbiting around and you need the stage pointed that way to do a burn. You'll fire those thrusters to turn the entire second stage and get it aligned and then shoot the engine off. So the reason why you have those little snowflakes flying around is because when you outgas nitrogen into the vacuum for a split second, it has some heat in the vacuum, and that heat gets sucked out completely really quick. And in that like fraction of a second where that heat gets sucked out, it'll solidify real quick, and then it'll stay like that in the vacuum. That's what those snowflakes are. You can also see some of it right there as well. That's solid oxygen though on the M1 DVAC or the M1 vacuum vent lines right there. That's solid oxygen. That solid oxygen on the vent lines of the second stage is there because after they fire the engine, they purge it out with helium. Now, if you outgas helium into the vacuum, it's not going to solidify. It'll stay as a gas and it'll just look like a puff. The kind of regime where helium will solidify is very, 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 you have to be very precise. So outgassing it into the vacuum isn't going to do anything. You're not going to see it solidify. But you will see the nitrogen and the oxygen do that. So that vent line, after they fire the engine, they shoot helium through it, and the oxygen gets pushed out through those vent lines on the side because you don't want to leave liquid oxygen inside of the engine. Oxygen oxidizes things. You don't want the engine rusting from the inside out. You think salt is bad? Liquid oxygen will rust stuff really quickly. So you can see a little bit of solid oxygen on the edge of the vent line right there.
Erosion, volume, and shape of the ground. With the Artemis program,
it's going to take a second to get there, Joe.
A sustained lunar exploration and try to land multiple payloads in close proximity to one another. SCALP's data will be a critical part of understanding these phenomena and improving our computational models to inform these future landings.
Let's head back now to Houston, where Josh Marshall is standing by live at Intuitive Machines headquarters with an update, and I'm sure very excited as well, Josh.
Thanks, Megan. With each passing minute, we are closer to receiving the lander's data in Nova Control. Right now, flight controllers are standing by for launch vehicle separation, followed by acquisition of signal. That's when the lander makes first communications contact, sending critical health and flight data into Nova Control. And we want to bring you closer to our Mission Operations Center to experience a few types of information that flight controllers are looking at during the mission. This particular screen is called the
science
Descent and Landing, or DDL screen. This screen is primarily used by the mission director and landing system experts. It's used primarily while Nova-C orbits the moon and through landing. The top right images of the moon are called the lunar tactical view. When the dots turn red, the lander is on the far side of the moon, and green is on the near side. The line is the tail where Nova-C is, with each dot representing 10 minutes of elapsed time. The acceleration sensed portion of the screen shows raw acceleration values from Nova-C's inertial measurement unit. This is used a lot during burn maneuvers and is a more robust.
They have accelerometer in X, Y, and Z. That's what the three lines are. That's good. This could basically tell you where the vehicle's going.
Data. Finally, the column on the right is a received, accepted, edited,
Relative
and
navigation.
failed pre-checked, or RAFE chart for short. When each of these lines are on top of each other, that's a good indication that Nova-C's navigation system is in good health.
Sweet.
That's because every measurement Nova-C makes must be received, accepted, edited, or failed pre-check. The failure
dope.
is a possible outlier
Show
of
us
data
this the
that the
entire
lander's
time.
computer automatically knows is bad information. Collectively, the DDL screen is one of many data displays that flight controllers are monitoring to successfully navigate Nova-C to the lunar surface. It's no small feat, and the tireless effort of our entire Intuitive Machines team has brought us to this moment, standing by for launch vehicle separation and acquisition of
February
signal
22nd.
in approximately 40 minutes. Until then, we'll toss back to Megan with more on the challenges that lie ahead of the IM-1 mission.
Yeah, that guy's a good
honest
commentator.
about it.
I
You know
like
how
him.
difficult it is to get to the moon. We haven't
Yeah,
done
he
it
could,
in
dude,
more
he
than
could
50
commentate
years,
golf,
but
man.
the CLIPS initiative
He's
is
got-
going to change
just
that.
got the inflection.
NASA and American companies who have teamed up to explore the moon know a lot of research needs to happen before astronauts head back to the lunar surface. In the end,
Darby.
the rewards outweigh the
And
risks.
French Invader, thank you very much.
Landing on the moon is hard.
Please
We're
do
going
that.
back. Under this Artemis program, we're going to be sending humans to the moon for the first time since Apollo. So ahead of humans, we want to get
I'm
up
not
as
sure, man.
much science exploration and technology experiments as possible.
So CLIPS starts facilitating a lot of the early science, the things we want to learn before we even send humans. CLIPS stands for Commercial Lunar Payload Services, CLPS.
The services part is the key element. Ordinarily, when NASA delivers a payload to the surface of the moon, they do it with a commercial partner, but NASA controls the building of the vehicle. Now, we're buying the service of delivery of our lunar payloads to the surface of the moon.
It is a delivery service, akin to a delivery service that you'd have here on Earth.
NASA will provide payloads to a commercial company. They decide how to get it to the moon. They have to develop their own lander, but they also have to manage the entire end-to-end mission.
It's meant to provide affordable, rapid, frequent access to the lunar surface through American companies.
We're funding different companies.
We have commercial companies that are competing to win task orders to deliver our payloads to the surface of the moon.
One of the goals when we started CLIPS was to help establish a lunar economy.
Somebody has to do it first, and then it becomes commercially available. Then they're able to crank them up. Then they're able to make it more affordable. And so the lunar surface is just the next frontier for a commercial environment.
But we had to acknowledge up front, all the way through the highest levels of the agency leadership, that some of them will fail. These missions may not be as successful as a traditional NASA mission.
We have accepted the risk of going through this innovative approach with these commercial companies, that there could be some failures. Some of them are new companies. None of them have ever successfully landed on the surface of the moon. So they're going to learn lessons.
We need to give our vendors the opportunity to learn.
And so that'll help ultimately buy down our risk as these companies learn, okay, what does it take to actually build up?
Okay, real quick, fellas, they're between ground stations. If you guys notice, the telemetry over here isn't updating. They should have an acquisition to signal through Gabon in probably about 2 to 3 minutes. Watch those numbers. They'll kind of, it'll look like a slot machine. It'll go and it'll change everything. Just keep an eye on it. It's out over the middle of the ocean. And no, they don't use Starlink. You don't want to change the antennas on a rocket. So you do, Falcon 9 is using antenna infrastructure circa 2013 or 2014, right? That when ground stations were there, is way before Starlink. Changing the antenna is just as complicated on a rocket as changing a rocket engine or changing a, fuel tank or something. It's a component that you really don't want to have to redesign and recertify the vehicle. So if it works, use it, right? So we have a loss of signal right now, which is once again why that telemetry is not updated. Watch, that number will tick in a couple of minutes.
And get more of a return on investment when we get to the moon.
CLIPS provides tremendous benefit across the scientific and economic communities.
So there's a lot we'd like to learn about the moon to help human habitation and prepare us for missions to Mars and beyond.
So the moon is the first step.
Flying on commercial missions will mean cost savings for NASA. To talk more about that, we have Joel Kearns here now. He's the Deputy Associate Administrator for Exploration in NASA's Science Mission Directorate. It's a very good morning, Joel. We just saw launch.
Oh, beautiful launch. Fantastic. It's great to be back here.
Yeah, perfect. So, how does NASA maintain oversight when it comes to this, the CLIPS vendors? Obviously, this is a new initiative for us.
Yeah. Well, remember, what we're doing here is NASA is not doing these missions. We're actually buying passage.
They did sell you. It had fuel lines going through the fairing.
Experiments and our cargo. So we have established this group of pre-certified 14 U.S. companies that we can go to and have them bid to do a specific mission for us, to land at a certain place of the moon, and to bring our cargo or our experiments with it. Once we actually select a company to do that, we assign them a NASA engineer who's their liaison. They represent all the NASA cargo and payloads to the company, and they represent the company back to NASA. As part of that, we get a lot of insight into how the company is actually going to do their mission. We try to make sure they really understand what they need to do to make our cargo successful, our data come back from the moon. And then we continuously learn from that, and we feed back and make sure that all 14 of those companies are certified to be able
Clips
to do
is a
this
good
work.
idea.
So a very collaborative
The
effort.
Bridenstiner
And
gave
you know,
us
we're
clips,
talking a
man.
lot about a
The
commercial
Bridenstiner.
economy. That's kind of the end goal. So how does that shape up with clips? How do we get there?
A couple of different aspects.
How'd they get George
when
Lucas?
when
Hey,
you hear
life
us talk
imitates
about
art,
wanting
man.
to form a lunar or a cislunar economy. In the short term, what that really means is encouraging the companies to get other non-NASA organizations to pay them to bring their experiments or their cargo on the moon. But it's actually a lot broader than that. Just by offering these contracts to industry and having them build their own missions that we can take a part of, the companies are developing their own, you would think of as a parts and high-tech ecosphere on Earth that's part of the lunar economy. Over the years, they've had to figure out ways to build these robotic landers. In some cases, helping other companies do new advanced high-tech components like rocket engines or fuel tanks or sensors, which didn't even exist 5 or 6 years ago. Of course, we can say now we're talking about small payloads going to the moon from commercials or having suppliers on Earth, but what the goal is in the long term is for these CLIPS companies to be able to take to the moon work or goods or services of other bigger companies that just want to do work in space.
So what would you say is the agency's confidence in CLIPS? You know, you laid out a very ambitious vision.
Yeah. Well, we think that the benefits of having this be successful,
US
where we
companies
go
right
out
now
to
moving.
companies, and in effect we pay for a service to get our things to the moon, it's just so positive that we really are committed to exercising this model and seeing how American business does. Now, NASA is a learning organization, so at every attempt that the companies make, we're always looking at. We're trying to learn from that and figure out how we're going to adjust things to go forward to do next. But we're really committed to this public-private partnership and service model that we've embarked on.
Joel, thank you so much. I appreciate you being here.
Thank you.
Okay, so the fifth NASA technology we want to dive deeper into is called ROLSIS, which stands for Radio Wave Observations at the Lunar Surface of the Photoelectron Sheath. There's going to be a quiz on that later, so I hope you all took that down. ROLSIS will use 4 antennas and a low-frequency radio receiver system to determine how nearby radio emissions from the Sun, Earth, and other planets could interact or interfere with science conducted on the moon. This experiment is something that has never been done before. It will perform many tests, including detecting solar radio bursts, radio emissions from Jupiter, and dust impacting the surface of the moon. ROLSIS could even serve as a baseline for a future radio observatory on the lunar surface.
Please.
Let's get another update from Josh Marshall, who's standing by live at Intuitive Machines headquarters in Houston.
Josh. And I think the lander is now teeing up here. He's probably going to use a 8-iron on that par 3. Hole number 4 here is, like I said, it's about a 150-yard par 3 here. He's going to tee up the 8-iron here. We got the pin cut short on the green. It's a beautiful day here. He's going to oh, sorry, that's something different.
Awarded the task order back in 2019. Even folks that started in the past couple years or the past few months have poured their hearts and minds into this IM-1 mission. In fact, every Thursday, Intuitive Machines holds a lunch and learn for folks to learn more about the company. And just a few days ago, one of our flight controllers, Brooklyn Herman, was describing today's events and said the opportunity to land on the moon has been a dream for her whole life.
Bro, curved monitors in a curved mission control. What are you doing with your life? All right? Intuitive Machines has a circular mission control room. You know why? I don't know. I was asking you. I have no idea, but that's really freaking cool. Complete with curved monitors. Curved monitors, curved room. It makes sense.
Starting with acquisition of signal, which we expect to happen just a few minutes after launch vehicle separation. For now, our team will continue to patiently wait and toss it back to Florida to introduce another IM-1 mission payload. Megan?
Well said, Josh. Okay, so the sixth and final payload has 3 telescopes that will help the spacecraft land safely. In the past, astronauts had to use a viewfinder or rely on radar.
So the Artemis program is taking NASA back to the moon, and everything that goes there, including the instruments and people, must be flown there safely and landed there precisely. So the
All right, I'm sorry.
landing phase of that task is one of the most critical aspects of it. NDL is a LiDAR instrument that is used to enable that capability. It uses light in the same way that sonar uses sound. For NDL, we have 3 telescopes where light would come out of the telescope, hit the moon's surface, and some of that light will be reflected back. These telescopes are mounted on the outside of a vehicle so you get a clear view of the ground as it's coming in for a landing. In the Apollo era, large radars or astronauts using their eyes looking out of a viewport were used to help land the vehicles. NDL is going to help to take the burden off of the crew with a much smaller, lower power, and more accurate instrument.
Cool.
Throughout
Laser,
the broadcast, we showed
optical
you each of the
rangefinders.
6 NASA instruments
That's cool,
that are
man.
bound for the moon. To talk more about those is NASA project scientist Deborah Needham. Good morning to you.
Good morning.
Beautiful launch.
A beautiful launch. So exciting.
So now we have 6 payloads bound for the moon. You know, is there a common theme among them?
I would say there are 2 themes to the payloads on board Intuitive Machines, the Odysseus lander. The first is demonstrating technologies for enabling future spacecraft to land more safely and more precisely on the lunar surface. And the second is characterizing the surface of the lunar South Polar region, which is an extremely challenging environment to operate in, and it's preparing us for sending humans to the lunar surface in advance of the Artemis missions.
Mm-hmm. So very precise things they're being sent for to study. So, you know, if they make it to the moon in 8 days, what happens next for each of them?
So even the payload's work starts even before they get to the moon. Intuitive Machines, while it's transiting towards the moon, will turn on the NASA payloads to make sure that they survived launch and are operating as we expect. And then you've heard about the RFMG, the radio frequency mass gauge. It will be operating the entire time all the way to the moon and down to the surface to make sure that it's monitoring propellants and collecting the data that it needs to achieve its missions. And then during descent, you heard about NDL, the Navigation Doppler LiDAR, and SCALPs. They're going to be operating during descent and collecting their data.
There it goes.
And once on the moon, Intuitive Machines will turn on our other NASA payloads, and they'll take turns collecting data until they achieve their missions.
How are these instruments selected?
Early on in the CLIPS initiative,
No.
NASA turned to
Oh,
our
yep, there we
scientists
go.
at the
It's
NASA
updating.
centers to identify science payloads and technologies that were relatively mature in their designs. We did that because we wanted the payloads to be ready for when the landers were ready to integrate them onto the landers and deliver them to the moon. So then NASA turned to the vendors and said, okay, you pick from this pre-selected list of NASA payloads which ones you think you can successfully integrate onto your landers and deliver to the moon. So Intuitive Machines actually chose the payloads that are on its delivery.
Deb, thank you so much. I can't wait to see what we discover with these payloads.
Me too. Thank you so much.
Thank you. Okay, so now we're going to step aside while we await our next big milestone, the second burn of the second stage of the Falcon 9 rocket, and then right after that, the separation of Intuitive Machines' lunar lander from that second stage. We are expecting that to happen about 20 minutes from now, so we will see you then.
Okay, so we had an acquisition of signal through Gabon here. Also, a dead giveaway for an acquisition of signal is that we have an onboard view. Up next, there's Dan with traffic. If Megan Cruz is a newscaster, Slider, and the guy from IM-1 is a golf commentator, what the hell does that make me? Happy Gilmore. Class Clown. Mystery Science Theater. Ladies and gentlemen, a flock of seagulls. Is it a low energy transfer or direct TLI? It's gonna get out there in a week. So that's actually. What's today? The 15th? It's going to get out there on the 20th. It's fairly high energy transfer, dude. With Methalox, you're awarded something like that. Yeah, that's fairly high energy. It's gonna, let me see, what's the transit time? 7 days. Yeah, that's, I mean, it's yeah, that's pretty high energy transfer for what it is. Kurt, I'm the local newspaper. Oh, thanks, Dick. Thank you. I'm not sure about the trajectory, to be honest with you, dude. Yeah, to be 100%. Not... The Apollo missions were the quickest, yeah, to like, for landing. Apollo is a three-day transit time. Yeah, a little bit of a reflection there. Yeah, Apollo took 3 days to get out there. That's what well, like, that's the thing, dude. Apollo needed a high energy transfer. The reason why it needed a high energy transfer is because life support systems don't last very long. So you needed a big mother to get it out there fast, so you don't run out of oxygen. Think about it. That's the power of the Saturn V. Yeah, so you want to hear something crazy? Apollo had it figured out pretty damn good. So, like, Apollo 11 spent about 23 hours on the surface of the moon, right? Apollo 17 was there for 3 days on the surface. On the surface. So, like, sleep on the moon, get out, go drive your car around on the moon, get back into the LEM, sleep, go out, do it again, sleep, go out, do it again, and then leave. The Apollo program was just starting to figure out how to, like, actually live on the surface. Yeah, Apollo 15, 16, and 17, each were there for 3 freaking days. That's how much they had that thing dialed in by the time, even after 6 missions to the surface, dude. Crazy, right? Play golf. That's right. Question about high versus low energy transfers. I know a bit about the basics of the several month-long transfers that can use 3-body gravitation to almost capture. Okay, what's your question then, man? How much changed since the spacecrafts between Apollo 11 and 16? Well, the Saturn V had an uprated variant that started flying with the Lunar J mission, so 15, 16, 17. But that... Yeah, 15, 16, and 17. They had like a Block 1B Saturn V going by then. A lot, dude. A lot changed. The baffle injectors on the F1s, for instance, that's not necessarily a Block 1 or Block 2 Saturn V upgrade, but like the LEM had the lunar rover on it. They eventually were able to outfit the CSM with some Apollo applications program, some AAP stuff. Like, I forget which mission. I think it was Apollo 16. I might be pulling that one out of my tail. Apollo 16 had like a telescope built into the cargo hold on the CSM, so they could take pictures with the CSM when it was orbiting up there by like with one person aboard. Yeah, they did a bunch of cool stuff, dude. Yeah, they did a bunch of really, really interesting things. I just really hope we could get back to it. Do high energy transfers have a low Earth apogee to travel there faster, or is there another trick? A high energy transfer would have a low perigee, not apogee. Your perigee would be extremely close to Earth, and your apogee would obviously be out near the like, well, to be blunt, about 250,000 miles that way. Yeah, Martin, the Apollo missions were absolutely insane. Like, but the good kind of insane. That's right, Kev, it will. Mm-hmm. I'm not sure you could do a 3-body three-body... Sajed, I don't think... And I agree with you. I don't think you could do a three-body transfer to the moon. I mean, you could, but why? What would be the point? A bielliptical... You could get away with a bielliptical Hohmann transfer or a ballistic lunar trajectory, which is like the lowest of the low-end transfers for bragging rights. I mean, Wicked, we put 6 flags on the surface of the moon for bragging rights, so, I mean, yeah, let's do it. Freaking bring it on, dude. Let's go. The low energy transfer that Peregrine used was 3-body. What was the third one, Saw? Do you work for NASA? No, Garbo, I'm just a space nerd. Yeah, just a space nerd. 6 flags. No, guys, we need whalers on the moon. With a harpoon. Yeah, that too is eyes up. Wait, no, that's just using Lagrangian points, my bad. I was gonna say, 3-body transfer means you need 3 celestial bodies. I don't think Lagrangian points count in a 3-body for a 3-body transfer. They don't count as a celestial body, right? So I don't know why how you could, like, I'm sure you could. I don't know how you'd do a 3-body transfer to the moon from Earth. That'd be impressive. I mean, bragging rights, right? Like, When Artemis 2 will land at the same moon base a couple of times, are they going to plant a flag every time they land? Artemis 2 isn't going to the surface, 7. It is a lunar flyby. Yeah, lunar flyby with the Orion capsule. Now, with that being said, I don't know if they'll plant a flag every time because they're all kind of all the Artemis missions should be going to the same spot. Technically, every Apollo transfer to the moon was a 3-body transfer because there were 3 guys inside. I guess I can't argue with that logic. Antelonio, what's going on? Can anyone send stuff to the moon? Like if Joe Barnard wakes up one day and decides to embark on a decade journey to send an impactor to the moon, you'd have to get certified with the FAA to fly, Salute. But yeah, I mean, I don't see why not. Yeah, they're going to be going down to the same spot, Drummer. Yeah, Lunar South Pole. Got to get at that water ice, dude. All right. T plus 36 minutes on the mission. Should be coming up here on second stage engine start, or SES-2. Smart idea. Why are you asking that as a question, Drummer? What do you mean smart idea? Yeah, of course it's a smart idea. You want to go where there's water because people need that to live. Or you could just get some Pocari Sweat. Pocari Sweat. You guys know that the Peregrine lander had a Pocari Sweat advertisement on it, right? And DHL. Second stage engine cutoff, Garbo. SECO 2 indicates that the second stage has done 2 burns. The first one was to get it on orbit. Second one here is... This is actually, well, this is a translunar injection burn. TLI for short. Pocari Sweat is good, but I'm more of an Aquarius kind of guy. Aquarius is where it's at. If we're talking about Japanese drinks. Silver Sol, the Peregrine lander, that the first commercial lunar payload services lander, had a Pocari Sweat advertisement on it. Not kidding. Aquarius is better though. Hot sake. Well, that's different. That's can't get hot sake in a vending machine in Japan. Actually, you might be able to. I don't actually know if that's true or not. So, Pocari Sweat is better, bro. No, it's not. Aquarius is better. Pocari Sweat. It has sweat in the name. That's weird. Nice, Sajed. Get your head out of your butt. Get your butt out of your head. Yeah. Reverse Uno card, man. It's not a water brand. It is a hydration drink, drummer. Okay? It's a hydration drink. Better than Power Gatorades. Yeah, exactly. It tastes better too, idiot. No, you're drinking the wrong water. Is that a Saber raid? Saber. What's up, man? Picari's sweat is pretty tasty, not gonna lie. Aquarius is better, dude. I'm telling you. What's wrong with plain old tap water? Desolate Aquarius comes in pouches like Capri Sun. Thank you very much. Oh, you can take those microplastics and cram them up your cram hole, LaFleur. Oh, hey, Saber, how you doing? Don't worry, I'm still crazy. I mean, wait, no. Okay. Serious face. Hey, man, what were you up to? I'm assuming they need to be in a polar orbit if they're going to the South Pole. How does that affect the conversation about what kind of transfer it'll be? Strider, you want to look up an NRHO, or a rectilinear halo orbit. Near rectilinear halo orbits. Yeah, very interesting for supporting a lunar South Pole base.
This comes after a successful liftoff of the Falcon 9 rocket with the Nova C lander called Odysseus at 1:05 a.m. Intuitive Machines,
Here we
an
go.
American company
Second
based in
stage
Houston, Texas,
thermal conditioning is
developed
started.
and built the lunar lander that is carrying, among other things,
You jump back into
NASA
KSP2 for the first
instruments.
time since
And if
before
everything
Force
goes as
Science came
planned,
out. How are
in 8
things here?
days,
Also,
mark your
we're all
calendars,
crazy.
February
These are great, man.
22nd, that
Great.
Nova C lander is expected to land on the south side of the moon. Let's go now to SpaceX headquarters in Hawthorne, California, where Jesse
H2O!
Anderson is live as we await that second burn and then spacecraft separation.
So what's going on here, guys? You can see the vents going. They're thermally conditioning the turbine machinery on the Merlin vacuum engine. Now, if that was Japanese, well, Ohio gozaimasu. Arigato. If that didn't make any sense, basically they're using super cold propellants, and this engine's been sitting up there in the sun. If you notice, they have thermal blankets over the turbine machinery where the fuel pumps are, right? So, solid oxygen. So what's going on here is they evac all the propellants out of the engine. That's what that solid oxygen is right there when they shut it off last time, because you don't want oxidizer. You don't want to leave oxidizer in the engine. It's not a good idea. It's bad for it. So to reintroduce the propellants into the engine, they have to chill it down. They have to get the engine to the right operating temperature. And in this case, the engine turbine, the turbine machinery on it needs to be super cold because you're using liquid oxygen. And now I'm going to shut up because it's actually going to do the thing now.
Screen is an excellent view from the second stage, looking at our MVAC engine with the amazing
nice,
view of
James.
Earth in the
Thanks for
background
those
there.
kind words, man. Right on.
The IM-1 lunar lander is still currently attached to Falcon 9's second stage at this moment. And
Looks
again,
like you ran into a laundry
SES-2
list of
and
problems.
SECO-2 are coming up here in just about 15 seconds or so. And hoping to be able to continue these live views here so that we can see SES-1 and SECO-2.
There we go. Good reignition. Get some solid oxygen just hanging out on the turbine machinery.
And
This
there
is a
you can see
recirculator manifold.
We have just had SES-1. You can see that MVAC engine has now relit. Again, this is just
that's
about a
lit,
53-second
chat.
burn, so just under a minute.
Where are you going? Oh, where you go?
And shutdown of this MVAC engine coming up here in just about 10 seconds or so.
Spitting straight fire right now. Dabs. Okay, they're shut down. Vent out. Helium purge. Stand by for a call for a good orbit insertion.
And there you can see
Nominal orbit insertion.
Like
The MVAC engine has
Clockwork.
shut down, and we did hear that call out for a
They make it look so
confirmation of good orbit.
Right, they make it look so
confirmation of a
easy.
good
It's
orbit,
just so
it looks
nuts,
like
dude.
we are on
You gotta be
track for
kidding me.
spacecraft separation in just a few minutes from now, just about
Frickin'
a little over 5
bruh.
minutes. Now, it's been a great launch so far. SpaceX did begin fueling of the IM-1 lander on the pad about 2 hours and 20 minutes before liftoff.
Yeah, Kev. 37.6 on the insertion. 37.6 on the insertion post SECO insertion velocity here. Yeah, that's high energy. That's a high energy transfer all day. It's not Apollo levels, but it's close. Yeah, good call, man. 24,000 miles an hour insertion, or 37.5. That's booking. That's real fast, man. I mean, look at how fast Earth is moving underneath it. It's quick.
Disconnect that attaches to new plumbing, and another set of quick
Lost the feed
disconnects
for a
that
second. There was
lead
a
to
signal
the
handover
IM-1
through
lander.
Diego Garcia.
And given
She's
the
booking
lack
AP.
of methane used on the Falcon program,
AP, let me just put it to you like this. This was near me like 40 minutes ago, and now it's near you. Which is okay.
now if you're just
Are we about to
now
go
joining
wave?
us, we are just about 4 minutes away. We're waiting
freaking 45
spacecraft
minutes, dude.
separation of the IM-1 lunar lander, which is still currently
said near,
attached
not on
to
top of,
Falcon
too.
9's second stage.
AP's over here.
And we did just a couple of minutes
Second
ago
stage will probably
had
be,
a
it'll
good
probably...
last and final burn.
So Panic, this is, oh, there was the signal handover right there. So what they're gonna do, most likely, the perigee is low enough, like at around $120, that when this, after the stage separates, it'll do one orbit around and then it'll burn up.
And
Careful,
just to
Ketcher.
recap,
See, I said
if you're
across
just
her
now
nose,
joining
not
us, we
up
did
it.
have an on-time liftoff at 1:05 a.m. Eastern Time, and everything has been
Yeah, it's
proceeding nominally.
bananas, dude.
Stage
Can you believe
separation
that?
occurred just about 2.5 minutes into flight, and that was followed by the successful landing
Actually, we
of
should
our
get a signal
Falcon
handover through
9's
Taz
first
here
stage
in a
back
second.
at landing zone 1, or LZ1, and that was the
Frickin' love
18th
rockets, man.
landing for this specific booster. Now, for those of you following along, this booster has supported GPS 3, Mission 3, Turksat 5A, Transporter 2,
Keep firing,
Intelsat
buttholes!
G33, and G34.
Yeah, Two Slider, I got you. It's all
Transporter
good.
6, and 12 Starlink missions. So pretty impressive and veteran
What's Earth-
booster
Earth
for
Escape?
today's mission. At about
Hippo, you talking about
2
leaving the
+
grav
7
well?
minutes and 46
Probably a little bit faster than this.
seconds, we
45,
did have a successful
if I had to
second
guess.
engine cutoff.
I don't
for
know what it is
SECO
off the
1.
top of my head.
That was the first burn of the 2 burns for this mission. That was followed by
It's actually probably
confirmation
not
of good
much more
orbital
than that.
insertion. The vehicle was then able to coast for a bit there, and then again just a few minutes ago we
The satellite will use the DSN AP, but the stage won't.
2 burns required to reach the targeted drop-off orbit for this
11.2
IM-1
kilometers
lander.
a second.
And now the vehicle is coasting with
Oh.
payload attached, and we are just a couple of minutes away from
Sure about that? I
spacecraft
thought it was
separation.
like, I thought it was 7.6 kilometers a second for Earth orbit. 11.2 would be escape. Does the lander have a main
IM-1
engine?
could
Yeah.
become the first U.S. lunar lander since Apollo's last landing in 1972, almost
Please.
50 years ago, and could be the first commercial lander to succeed in reaching the moon's surface. So again, we are just about a minute and a half,
Oh,
just under a
signal
minute and a
handover.
half away from spacecraft separation. And on your screen, as we wait to
It's
to get
probably
some
not
live
complete
views, you
TLI
can see on your
panic.
bottom
It's
right-hand
probably close.
screen
The lander's
speed
probably
and
gonna
the
finish it up.
altitude, of the Stage 2 vehicle.
This is
Again,
definitely
still
close to
carrying the
TLI with those
IM-1
numbers.
spacecraft.
Oh.
And there's that live view there. Again, this is a view from the second stage vehicle, looking aft at our MVAC engine there.
That's nice.
We are patiently
some EJ
waiting
Big Happy emotes in
spacecraft
the chat.
separation here, just under a minute from now.
Yeah, Derek, it really doesn't. Yeah, TLI is translunar. Yep. You got it.
And now that we have this live,
dude,
perfect timing. That was great live
that's
move.
sick.
The IM-1
Yeah,
lander,
baby.
Right before it begins its 8-day journey to the moon.
Oh, that's awesome. All right, here we go. Coming up on deploy. 48 minutes in.
Very exciting that we have spacecraft separation coming up here in just a few seconds.
IM-1, Odysseus lunar lander separation confirmed.
Go, baby, go. Dude!
What an incredible sight to see. The IM-1
Yes!
Nova C lunar lander
That's
drifting
awesome!
away from Falcon 9's
Come on,
second
please
stage,
land.
confirming spacecraft separation.
Oh, that's
From all of
badass,
us here at
man.
SpaceX, we are wishing
What
the
a
IM-1
shot.
lander a great flight and safe travels. SpaceX is honored to be a part of NASA's Commercial Lunar Payload Services
That's
initiative to
kick-ass,
deliver
man.
science and technology
Dude, have you
to
seen
the
this?
lunar surface. And we thank NASA and Intuitive Machines for entrusting us with today's historic mission to the moon.
I love this. I love this stuff.
For
It's
those
so
of you
good.
following along,
It's
you'll know
so,
that this mission marks our
so
14th of the year and second just today.
I'll be out there on the
Congrats to
22nd,
the
Wicked.
SpaceX team. We're just in February, and we've already launched in partnership with NASA missions like Axiom 3, Cygnus, and PACE. And we're gearing up for the Crew 8 mission before the end of the month. Check out spacex.com/launches for up-to-date missions and schedules. And before we sign off, let's go back to Josh at Intuitive Machines.
These
Josh?
guys popping the keg yet or what?
What an incredible view. Just a few moments ago, our flight controllers inside of Nova Control heard that confirmation of launch vehicle separation. This starts the countdown toward our lunar lander's autonomous commissioning. During this milestone, the lander is going through the steps required to power on, determine its position relative to the sun, and make communications contact with flight controllers in Nova Control. It's an autonomous process that takes several minutes. In that time, we'll walk you through what's happening in space approximately 223 kilometers or 139 miles from Earth. At launch vehicle separation, a spring force gently pushes Nova C away from the launch vehicle's second stage. We just saw that, allowing the lander to deploy and drift away toward the moon. Brake wires connected to the launch vehicle let the lander know it has deployed, and Nova C starts an internal timer to count down to when it's safe to turn on. After the timer finishes, Nova C's primary systems are expected to autonomously power on. This includes guidance, navigation, and control, or GNC for short, automated flight management software, radios, sensors, and thermal control. The GNC system powers on the cold gas helium reaction control system to stabilize the vehicle's attitude, because at this point, the lander does not know where it's pointed, but it can stop any residual spin motion. This is much like a person spinning in a chair with closed eyes can stop spinning without knowing which way they're pointing when they stop. After controlling the spin rate, special cameras known as star trackers autonomously match images of the distant star field and provide Nova C with its orientation. Software then takes those star tracker measurements and processes them through an algorithm known as the Kalman filter to correct the onboard orientation.
Stop
The
making
lander
up
now
words,
has
I
two
swear.
critical data points.
If you have
Its
questions, I'll
attitude
explain
relative
it.
to the star field and a reference position from the estimated launch vector. With these data points, Nova C may command its reaction control system to maneuver the lander's top deck solar array toward the sun for illumination, generating maximum power. All of these steps are expected to be happening right now, and when autonomous commissioning is complete, our Nova C lander named Odysseus turns on its communication radios and makes first communications contact known as acquisition of signal, or AOS. Making that communications connection involves more than the lander's operations in space. It takes careful coordination here on Earth too, using Intuitive Machines' Lunar Data Network. The network was designed to support NASA's
He's
CLIPS
good.
initiative, government services, and other commercial efforts using line-of-sight and data relay services for spacecraft in cislunar space, which also includes low Earth orbit. The secure network is made up of Nova Control, which we're keeping our eyes on right now, and strategically placed ground stations spread across the globe. The ground stations are expected to provide near continuous communications with Nova-C during the entire IM-1 mission. With that entire network available, our flight controllers responsible for communications and ground stations will be the first people in Nova Control to start seeing data from our lunar lander, which means the ground station assigned to this part of the mission has locked onto Odysseus's signal. Now, from the lander to Nova Control, all of these innovations and capabilities are being put to the test right now as we prepare to enter our nominal acquisition of signal window with Nova-C. Right now, we are listening into the mission audio loop and looking live into Nova Control.
SpaceX just deliver us the OPM file.
Okay, copy. You're good to process in the background while we work contact.
Okay, I'll work with Fido on this.
Seriously, that mission control is baller.
Right now, we estimate that the lunar lander is traveling about 10 kilometers per second, which is about 24,600
All right, I want to make sure
miles
Com's
per hour.
happy with it. Com?
It's awesome, Retro
Standing
Goblin.
by.
That is the
I
coolest.
don't see packets updating in packet counts unless I'm looking in the wrong spot.
That's the coolest mission
and
control
I'm
I've
not seeing anything
seen
populate in AOS.
Yeah, those jackets are baller.
So we're still standing by for
they're
autonomous
Columbia jackets.
commissioning and making that first ground
bigger than me.
communications from the lunar lander in space. We expect the carrier lock call to come from the COM or ground network stations inside of Nova Control. And this is Houston's first commanded lunar mission since Apollo 17.
All right, I see packets. And I see...
All right, guys.
And there
means
we have it.
they
We have
got a signal
packets.
lock.
That is Michaela Landavart
All right, guys.
on the ground.
Com, I want your report. Uplink and downlink, what do we got?
Okay, so I am seeing packets populate on the AOS screen and in the packet counts area. Looks like telemetry is coming in pretty well. We have not started uplink, so we do not have uplink locks at this point. But it looks like we are seeing most everything that we would expect as far as
That's an
downlink.
excellent call. We have reached a pivotal milestone. We're going to bring it back into the broadcast booth and congratulate the team inside of
Come
Nova
back.
Controls.
No.
Our Nova-C lunar lander has successfully separated from the second stage of the launch vehicle, autonomously commissioned, and made first communications contact with Nova Control. What an achievement for the entire Intuitive Machines team.
Oh, I could listen
Let's
to that
honor
loop all
this
day, man.
momentous milestone and prepare for the challenges and triumphs that await us on our lunar journey. From Intuitive Machines' Nova Control in Houston, Texas, thank you for joining our portion of the IM-1 mission broadcast. We'll toss it back over to Megan in Florida for reaction to this successful launch of our IM mission. Megan.
Yeah, from here at NASA, we just want to say congrats to Josh and Intuitive Machines, another successful CLIPS launch and orbital insertion of a commercial lunar lander. Now, hopes are high that a U.S.
Yeah,
commercial
that
lunar
guy's
lander
damn
will
good
make it
commentator,
to the moon.
dude.
Joining me now to talk a little bit more about that, and this program is Chris Culbert, and he is the CLIPS program manager. Exciting to see this unfold right in front of us, huh?
Yeah, this is great. SpaceX gave them a wonderful ride, great launch, really clear sky. We could see it all the way up to the well, not to the moon, but on its way.
We saw the moon in the distance.
We could see the moon. It was a great launch. This is a great step. It's a lot of hard work to get here. This is 5 years of effort from a very small company, but they've made a lot of progress. They solved a lot of problems, and now they're on their way. So this is a good start, but it isn't the end yet. They got to finish the next step.
That's right. But at least we have 8 days, right?
We
have
do.
8 days.
Yeah. So they've got 6 days to get to the moon, and then we'll hit the hard step.
Yeah, so with the challenge of landing on the lunar surface, what's your message to the Intuitive Machines?
So the big thing right now, they need to stay focused. Space is hard. Small mistakes can doom you. We know they're very talented. They're very well organized. We're really impressed with the depth and technical skills of this team.
Sweet.
But you have to stay focused. You got to make sure you nail everything and stick the landing.
So again, a lot to look forward to, but we're optimistic.
Yes, we are. We're looking forward to it. I got a lot of faith in these guys.
Great. Chris, thank you so much. Glad to be here with you again for another CLIPS launch.
Thank you very much.
Okay, so that is going to wrap up NASA, Intuitive Machines, and SpaceX coverage of the launch of the Nova-C moon lander on a SpaceX Falcon 9 rocket from pad 39A here at Kennedy Space Center. Again, if all goes well, Nova-C is expected to land on the moon 8 days from now, so mark your calendars, on February 22nd. It would be the first U.S. landing on the moon since 1972. We'll, of course, bring you that coverage live right here on NASA TV. And until then, you can find out more about this mission and other NASA CLIPS launches by going to the link we're about to show on the screen here, nasa.gov/CLIPS. We're going to leave you now with a replay of today's launch for everyone here at NASA, Intuitive Machines, and SpaceX. I'm Megan Cruz, and have a great morning.
15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, and liftoff. Go SpaceX, go IM-1 and the Odysseus lunar lander.
Vehicle pitching downrange.
Dude, we're sending stuff to the moon, and like a lot of stuff. That's awesome. Oh, I'm here for coverage, man. I'm not missing that landing. What are you, nuts? Oh, mama. That is, I mean, it's not moving. All right. What's the uptime? 14 hours? Psh, GG. Easy. So I'll pitch you the question I asked NASA Spaceflight voice chat last week after you left. Do you think we've approached Apollo levels of space exploration again? I think we're there, at least goddamn close. Ian, if we're going to count Mercury, Gemini, and Apollo as like kind of one contiguous thing, I would say we're in 1967 in terms of... Now, in terms of exploration, we're close. We're close. We can taste it. We can taste it. But we're still in low Earth orbit. Right? Think about it. 1967, Saturn launched, Apollo 4 launched, right? Did a test mission, but we're not there yet. It's going to be a little bit longer. Right? However, in some facets, we are eating the Apollo program's lunch. For instance, at this point in time, NASA was launching people into space basically on top of an ICBM. We have Falcon 9. Now, if you're comparing Titan II Gemini launch vehicle to Falcon 9, there's no comparison. Falcon 9 with Dragon is better in every way. Every single way. So, I'd say in some facets, dude, we are eating their lunch. But when we set foot on the moon, that's when it's gonna be real. You know what I'm saying? No, that's when we'll have surpassed, I think. Overall space program, yeah, I'd say we are trending very much in the direction of surpassing them. But Ian, like, you gotta think about this, dude. NASA would have salivated over having a vehicle that can launch almost every day in the 60s. They would have salivated at that. Yep. There's truly a spaceflight renaissance going on, and it's pretty good, man. It's pretty good. Yep. So that booster that just flew, if I'm looking at this right, hold on. That was 1060, flight 18. With the exception of 1058, there's only, which is no longer with us, there's only one other booster that's flown this much. I think it's 1062. 1062 is at 18 flights, but I'd have to go and check it. 300th Falcon 9 mission. Like, see that kind of stuff, Ian? No, the Apollo program wishes it could do stuff like that. SpaceX is past, they're past them. In terms of overall exploration, though, yeah. We're close. But we are pushing to surpass them and then stay past them, you know what I mean? Falcon 9 is the Saturn 1B we deserved. Dude, I said it once, I'll say it again, man. SpaceX, the Falcon 1 program with SpaceX is akin to the Mercury program, with the exception of people. Falcon 9 is the Gemini program. Starship's the Apollo program. And when we get to that point, it's gonna get fun. It's really gonna get fun. It's gonna get fun. That's gonna be sweet. That's gonna be awesome. That's gonna be pretty cool. It's gonna be pretty awesome. Also, at this point, the U.S. alone has 4 super heavy launch vehicles active or deep into development compared to 2 worldwide in the 60s. It's crazy. Dude, in many ways, we're behind them, but in many ways, they wish. They wish. It's like, it's very interesting to compare. Sorry if this is a frequent topic, but do you have any strong opinions on the Gateway? You know what, Quick Integrated? I don't have a problem with Gateway. I think Gateway is a good idea. My problem with the Artemis architecture is that Orion can't get to low lunar. That's a big problem. What if that is a huge portion of your mission that you're just solely relying on the lander, to the point where it's almost more complicated than the Apollo program. Because considered like Apollo program the lowest factor of difficulty here. That was the simplest way to get somebody to the moon. We're opting for a much more complicated architecture, and while that's fine, that's okay. There's nothing wrong with that. I mean, if we're going to go to the moon sustainably, I would really like to be able to have a little bit more leeway in the Orion capsule's flight regime. I don't necessarily have a problem with Gateway. Gateway's a pretty damn good idea. Yeah, I don't mind it. My thing, and that leads me to the other thing with the Artemis program. You know, the Artemis program's main goals are to go back to the moon sustainably, but in the same breath, they want to go back to the moon once a year sustainably. Once a year, sustainable. Pick one. Pick one. That's what? What do you mean? No. 4 times a year. We need to launch more, not less. You need to get better at going to the moon, not go there once and then, okay, wait a little while and go there again and then... No. You want to make this a routine thing, and more importantly, you want to prepare for a Mars mission, we need to be out there. You have to be out there. I, too, can parrot Destin. Oh, Elliot, shut the fuck up. I've been saying this for a decade. Kiss my ass. You parrot Destin nonsense. I've been saying it for a decade. He says it once, and you say I'm copying him. Shut up. It's 2 in the morning. I've been streaming for 14 hours. I'm not playing that bullshit.
Discovery, go at throttle.
Whoa! Gator, don't play that. I'm kidding. I know. Sorry. No, I'm having fun. I'm having fun. I'm not actually mad. Don't leave. Hey, what the hell? Weather guy, why'd you let me make these things show up in front of my face?
Throttle up.
First time I heard you cuss in a long time. It's because I'm having fun, man.
Discovery, go at throttle up.
Yeah, Elliot, I know. It's just messing around. But seriously, though, shut up.
Discovery, go at throttle up.
Some more workers and resources. Drummer, if I didn't have to get up for a stream in 10 hours, I would absolutely do it.
Discovery, go at throttle up.
Tomorrow is going to be a short stream, though. I gotta take, I postponed my date with Remo for Valentine's Day because there was 4 rocket launches today. So she's kind of expecting me to, you know, do that tomorrow. I don't know how I was able to talk this
Discovery,
through,
go at throttle
but,
up.
you know, you know, I gotta go to bed. Hey, Loopy, this is the 6900th image in my account. Nice. Oh, very nice boost back. Very good, very good. So, yeah, guys, tomorrow's probably gonna be a shorter stream, but I will see you around.
Discovery, go at throttle up.
I'll see you around noontime. Weather Guy, thank you very much for the 10, dude. I really appreciate it. Thanks for the 10. The 10. Yep. Still got it. And it was only off 1 cup of coffee, baby. 1 cup. One cup, 14 hours. 1 EJ, 1 cup, no. I'm gonna leave now. Yeah, this is weird. Okay, so thank you very much for watching, everybody. I do appreciate it. We're gonna wrap it up here. And on that bombshell, it's time to end. Thank you very much. Good night. Still here? Go. Stream's over. Go home. Thought I left, didn't you? All right, I'm really going to go this time. You didn't send us anywhere? Do you want to be sent somewhere? All right, fine. No! Italics. Raid him. Go. 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 Go! Emilio! 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 I'll see you guys go raid at town. Emilio! Oh, I love that movie. All right. I'll see you guys tomorrow. Also, Emilio! I'll see you. Raid at town. Go. Thanks for watching, everybody. Love you guys. I'll see you.